Welcome to this video. In here, I'm going to introduce bias and variability. Whenever we cannot measure our entire population, that is, every time that we measure a sample of our population to draw conclusions about the entire population, we need to consider both the bias and the variability of our test statistic. Fortunately, management of both bias and variability has rather straightforward. Recall that a statistic is unbiased if the mean of its sampling distribution is equal to the true population parameter that the statistic is estimating. In AP statistics, we assure ourselves of an unbiased statistic by always being sure to take an SRS. Recall that the variability of a test statistic is described by the spread of its sampling distribution. For means, the standard deviation of the sampling distribution is delta over square root of n. For proportions, the standard deviation of the sampling distribution is square root of pq over n. To reduce the variability of our test statistic, we can simply increase sample size. So here is a diagram showing the relationship between bias and variability. So see this upper left corner diagram. It has a less variability, so small variability, but it has a large bias. So if you shoot a lot of arrows, try to hit the target, a lot of your shots has been clustered into one group, but they're all very far away from the target. And see this upper right corner, it has both large variability and bias. So they're both separate out and not near the target. And see this diagram here, it has low bias and low variability. So that's our goal. We want this. And this diagram shows high variability but low bias. So it varies a lot, but they're all near the target. So let's kind of summarize a little bit for what we learned, both from this video and from last couple videos. So sampling distribution for proportion, again, if you want to draw a normal curve for this, it's a bunch of sampling proportions summing up to create a normal curve. So first is simple random sample. That's the first condition we're going to check. That determines our center. And if simple random sample is met, then the mu of p hat is equal to p, which means it's unbiased. Second condition, also known as 10% condition, it determines spread. So the standard deviation of p hat is equal to square root of pq over n. It determines variability. Third condition is np greater than 10 and nq greater than 10. It determines the shape. Therefore, it gives us the normal curve. Sampling distribution of means. And this is the normal curve for summing up a lot of x bars, the sample means. So the first condition is simple random sample, same as the last one. It determines the center, and if this condition has been met, the mu of x bar is equal to the mu of the population. The second condition, 10% condition, determines the spread. If it has been met, then standard deviation of x bar is equal to the standard deviation of the population divided by the sample size, square root of sample size. Third condition is population is normal or n is greater than 25. So if the original population is normal, whatever size of n is, it will all be fine. But if it's not, then n should be greater than 25 for us to draw a normal curve. It determines the shape. We can draw the conclusion that sampling distribution is approximately normal. And that's all for this video. So the goal for this video is just to help you get a good idea of bias and variability and familiarize with this diagram. I hope you learned something from it. Thank you so much.